Hello, this is Matthew, and welcome to today's video in which we are going to Sysgen a new, fresh VM370 system. Now, why would we do that when there are really nice prepackaged distributions from the community, like the venerable 6-pack version 1.2, or now this has evolved into the VM370 Community Edition releases? And the answer certainly isn't because we're going to end up with a better system. In fact, we are going to end up with a very, very bare minimum, and I'd say barely usable VM370 system. Again, just the bare bones base as it would have been delivered by IBM in 1979. So that's not really the why. I think the why, as usual when we're doing stuff on this channel, is mostly just because we can and we like to learn. I've really only used the 6-pack system, so it'll be interesting to see, what that bare VM370 system is like. Interesting to see what the process is to install it from tape. And if I want to look at VM370 system programming and system modification in the future to see what kind of things you might have to do to get it to the state that we are at with the community, I'll say community edition, that's after the 6-pack V12, but what are the kinds of things you do to alter the source code of CP and CMS to add some of the nice features that are available in these pre-made distributions? So, unlike MVS 3.8, where we were able to build up that system using the really wonderful instructions and all of the materials that Jay Mosley put together, those were some videos early in the life of this channel. I'm just going to be following the IBM manual for this. So we're not going to get anything extra. We're not going to get anything cool. We're not going to get anything that ends up making the VM370 system feel pretty modern and usable like we're able to get when we use MVS 3.8 these days. So if you're interested in that, stick around and we'll go through this whole process from scratch. If you don't like sitting around for, let's be honest, this is probably going to be an hour and a half or 2 hour long video. If you just want to see the instructions, the good news this time around is we are just literally going to be going through step by step the instructions that IBM provides, and then some supplemental instructions that are in the memo to users for the service tape that we're going to use to apply some service to the system. So you don't have to sit and watch the video. You can just read the instructions if you like following the instructions on paper. So with that, let's get going. This is the last we're going to see of the VM376 pack. So let's switch over to just our blank empty terminal here. I'm going to make a new directory to hold all of our work. So we'll make VM Sysgen. And it is indeed just an empty directory. You know we're going to have a bunch of terminal windows that we need to keep track of. So I'm going to run this under tmux here, and then we'll start stacking these up as we get into it. But let's switch over to a web browser and start there. So if you look at the cbttape.org site, they actually have some VM370 R6 materials, and they've archived what was one of the original distributions for the community of VM370 R6. And then if you look at this other distribution here, yeah, here we are. So Bob Abels put together what was one of the early systems. This is probably even earlier than the 4-pack system. And what we have here is the starter system tape. So this is what IBM would have sent you as the starter system that you can IPL from to then do the system generation, as well as a service tape, so PTF at level 616, if that's what that number indicates. And you actually apply some of the initial service during the system generation process. So you would have gotten those 2 tapes from IBM. Now, what Bob Abels did here is he actually did the installation to 2 DASD volumes and then backed up those 2 DASD volumes to tape. So the idea here would be you could get a Hercules configuration and the DDR, either tape or card deck is probably in here. IPL from that, restore the tapes to your hard drives, and then you would have a pre-installed VM370 system. But we don't want the pre-installed system. We are interested in the actual original distribution tapes, and then we're going to do all of the work ourselves from scratch. So let's download those tapes, and we can go over here grab that one and grab the PTF tape. Looks like those are bzipped, so I'll just for X and start.bz2, bunzip to X. Great, we have those tapes there. Now, I mean, we're also going to need Hercules. So when I said we're starting from scratch, I wasn't kidding. So I'm going to use the relatively recent fork of the Hercules Hyperion work that was made by Jay Maynard. So that's called Ethra. I believe I'm pronouncing that right. So if I search for Hercules Ethra, there we are. Now I should say VM370 R6 will work with really any version of Hercules. You can use Hercules 3.11 still, or 3.13 if your distribution, like if you're using Debian, just apt-get install Hercules. You'll get a really nice stable Hercules 3.13. You can, of course, use SDL Hyperion, or you can use this new Ethra branch. So I'm just going to clone that. Let's git clone that. And go into the directory here. We'll configure it. I'm just going to install it in, let's just go home VM Sysgen. We'll put it into a folder called Hercules here in our VM Sysgen directory. So configure will just take a second here. And then I'll run the make. I'm just running it with nice. So even though I told make to use all of the CPUs in my system with that -J, it'll run at lower priorities so that it doesn't, I don't know, interfere with my video recording software here at all. This will take less than 30 seconds to compile here on my system. So we'll just watch that go by. And before you know it, we will have our freshly built Hercules. Yep, there we go. So we'll just make install that, and that'll put it in the VM Sysgen Hercules directory. Very good. So if we go back up to Hercules bin, we can confirm here that we do in fact have a copy of Hercules built. Let's add that to the beginning of our path. So that'll just be print working directory. Make sure we still have our old path there. And now if we just say which Hercules, perfect. It's picking up the Hercules there that we just built and installed. The other thing I want to download and use is going to be Virtual 1403. So if we search for Virtual 1403, oh, there it is. You can either go right to my GitHub repository, or you can go to the hosted Virtual 1403 system that Moshix hosts if you want to use the online capabilities of Virtual 1403. If you go to the setup instructions, that has a direct link for the Virtual 1403 agent binary, and then that'll take you to the releases page of the GitHub repository. So I'm just going to download the pre-built binary here for Linux AMD 64. You can grab this for Mac OS, either Apple Silicon or Intel Macs, as well as Windows. And we have your Raspberry Pis covered if you're using Hercules for Linux on a Raspberry Pi. But in any case, AMD 64, copy that link, and let's download that. And we'll just extract that. Perfect. Don't really need the release anymore. So if you look at the default Virtual 1403 config file, you can see it's going to try and connect to Hercules on localhost port 1403. So when we make our Hercules configuration file, we'll just have our printer listen on port 1403. And then again, you can use the online mode if you sign up for an account and paste in your access key here. But for the purposes of this video, I'm just going to have it spit out files into a local directory. We won't get the nice vintage mono 1403 font that Moshix licensed for that online service for the community to use. But we will get IBM Plex Mono, which, while not an accurate 1403 printer font, I find to be just a nice monospaced font nonetheless. So these are going to go in the output directory PDFs. So the only change we needed to make here was just mode local. All right. Do we need anything else? I don't think so. We have the tapes to install VM370. We have Hercules. We have Virtual 1403. I think we're ready to go. The only thing we're missing are the actual instructions that we're going to follow. So if we go back to the web browser, let's go to bitsavers.org. And luckily, we have the correct version of the IBM VM370 Sysgen guide for those VM370 R6 tapes that we have. So you can go into their computing archive, and these are all alphabetical. So we can just go down to IBM. And this is from the S370 era. So find 370. There we are. And then there's a VM folder directory in here. There's VM. Okay, so VM370, release 6. So much like MVS 3.8 was the last version of the MVS line of operating systems that came out kind of pre-1980, really 78, 79, when IBM started asserting copyright on the operating systems themselves. VM370 release 6 was the last release that is generally considered to be in the public domain. VMXA, I believe, is what came out after that. And really, VMXA is when you get Xedit, the full screen editor for CMS, which is really probably the biggest piece of VM370 that's missing. There are the EE editor, there's some full screen editor work and some hacks on VM370, but it's not quite the same. But in any case, VM370R6 is what we have to just freely use with Hercules, so we can still have a lot of fun with it. And what we're interested in is the Sysgen guide here. So, VM370 Planning and System Generation Guide. This is everything you need to install and configure your new VM370 system. So it's 522 pages. There's a lot of information in here. You'll see if we look at the table of contents that not only does this cover the Sysgen itself, but if you look at, let's see, so it has thoughts on 3270 terminals. VM370 really originally was built for typewriter terminals, line terminals. The 3270 support is just kind of a late addition to make it barely work. But again, it's nice because the community has done some kind of hacks to make more full screen stuff work in VM370. But there was some early thought on using 3270s with it. But yeah, what I wanted to point out here was it tells you about mini disks, which are really the core concept of virtual disks for your guest virtual machines. But this is also the manual that covers the directory. So somewhere in here, yeah, creating your VM370 directory. So even once you've installed the system, you're frequently editing the directory to make your virtual machines. So it really can talk about what some of the statements are and preparing for your new system, what you want that initial directory to have, some sample directory entries. So a lot of good information here in the manual. But we're going to skip ahead to page 229. This is the section of the manual, or really part 3 around page 225. This is the section of the manual that talks about generating the new system. So I have a note here. The actual PDF page number is 255. And there we go, part 3, generating VM370. So let's see what this has to say. Essentially what we need are 2 real disk drives. So these are going to be our DASDs that we're installing onto. At least 1 real tape drive, but it's easier if you have 2. So we're going to splurge and spend that extra money on a second tape drive in our Hercules mainframe. The scratch disks, these are actually just the 2 real disk drives that we're using. So we're going to have the starter system on 1 disk, and then we're going to build our new system residence volume on the other disk. We have our starter system tape. We have our put tape, program update tape. This is that PTF tape. And then we're going to need just a blank tape because the process is going to write some data to tape. Now we have the 3330 starter system. It's possible to build a 3350 residence volume from the 3330 starter system, but it's a little bit more straightforward for us to just build a 3330 system residence volume from the 3330 starter system tape. And there's really no disadvantage, right? We can still add as many 3350s as we want later for any page space, temporary space, spool space, all of the user mini disks. We're not really going to be at risk of running out of space on our 3330 system residence volume versus if we tried to build onto a 3350 residence volume. So just to keep things simple and avoid some additional complications, the 3330 starter system comes with examples for a lot of the configuration files we're going to need for a 3330 system residence volume. So we'll just keep it simple and build onto a 3330. When we do define our system, though, we'll make sure that we're including device addresses where we can add all of our future 3350 volumes. Okay, general information. Again, you can read all this if you're interested. It does sort of teach you a lot about the process and really how the whole VM system works. But here we'll just dive into the steps for generating. So step one, we need to load the format program from the starter system tape. So obviously before we can do this, we need a mainframe. So the first thing we're going to do, which of course isn't covered in this guide, is we are going to put together our mainframe, which means we're going to write our Hercules configuration file. So let's make a file called hercules.cnf. That's just the default file name that Hercules reads if you don't provide it a configuration file name. So I just always name all of my Hercules files hercules.cnf. Whenever I download things like the VM 376 pack or other things, I just rename their config file hercules.cnf. Who wants to do all that other typing? So this is going to be a pretty simple, basic config file. We don't need a lot for VM370. We are going to be running in S370 mode, of course. I always like to say OS Tailor quiet, just so we don't get any extraneous information spewing out on the Hercules console. You really only need that information if you're trying to debug Hercules itself, if something's going wrong. The S370, VM370 is a 24-bit system, so the most RAM we can have in our box is 16 megs. So we're going to spend all the money and give it 16 megs. You need to tell Hercules the maximum number of CPUs and then the actual number of CPUs you want in your system. We're just going to build a single CPU system. We're not going to build attached processor support. I am going to switch to a different than default code page here. I've noticed if you don't put in a code page, the default code page doesn't handle the vertical bar character, the pipe character in the virtual 3215 printer terminal, the telnet console. I think it works fine in 3270s, but we're going to start out with the typewriter terminal. And while we don't need to type the vertical bar, the prompts sometimes do display it. So it's just a cosmetic thing, but this will display those correctly. I think that's it in terms of Hercules directives. So now we just need to start defining our virtual hardware. So as I mentioned, we're going to use a typewriter terminal. So that's a 3215. And I'm going to give it the no prompt option just to avoid an annoying Hercules prompt every time we enter something. And then we'll have our basic unit record devices. So the standard addresses for all of this is always a reader on address C. That's going to be a 3505 reader, and we just need to prime it with something. So I'm just going to say dev null, and then this is going to be an ASCII device, so it'll do ASCII to EBCDIC translation for us. And EOF, I believe, means that Hercules will send a particular type of attention interrupt to the operating system when we feed in a new deck of cards. D is the traditional location for the card punch. So that's going to be a 3525 punch. And again, we'll give it a file name. So we'll punch to the file pch00d.txt. And we would like ASCII translation on those. And then E is going to be our venerable 1403 printer. And again, you can just give this a file name, so like print00e.txt. but I want to use virtual 1403. So I'm going to give it the socket I want to listen on. I'll just listen on all of the IP interfaces on port 1403, and that's going to be a socket device. So that's it for unit record devices. Now we will load a couple of DASD volumes. So we will have the starter system DASD. This is going to be a 3330, and that's going to be called CPR6L0. That is the volume label that the instructions tell us to use. So we'll create this with DASD in it, but I usually like to put the type in the file name. So CPR6L0.3330. And then at address 131, which will also be a 3330, will be our new system residence volume. So that's going to be vmrel6.3330. And again, this label is strongly recommended, if not required, by the instructions that we're going to follow in IBM's manual. So we're not going to argue with IBM. We're just going to use what they tell us to use. Now, in the future, we can put our 3350 volumes in here. I'm going to say that addresses 150 to 15F, maybe, so 16 devices there, we will put in our real IO configuration as 3350 disks. So again, if you want to add those 3350s for your CMS user mini disks or disks for other virtual machines you want to allocate mini disk space on, if you want to use 3350s, we'll just assume that we're going to put those at those addresses. And we're also going to need some tape drives. So I'm going to give us, well, we may as well have 8 tape drives. So I'm just going to say 8 tape drives. These are going to be 3420 tape drives. And eventually, although not for the initial system generation, we're going to want some 3270 display terminals. So those are going to be locally attached 3270s. I'll just make 8 of those as well. And those will be 3270s. So let's just double check that. I think that's all we need. We have the basic Hercules config to give us a nice 16 megabyte of main storage S370 mainframe with 1 CPU. This is going to be our system console. We have our basic unit record devices in terms of a reader, a punch, and a printer. And we have the 2 DASDs we need. We have the tape drives we need. And we have our future 3270 terminals. So that should work. Let's save that. We need to create those 2 DASD files. So we'll use DASD in it. Probably not relevant for however big these 3330s are, but I always do -LFS. That'll keep it all in one file instead of splitting files up on, I think, 2 or 4 gig boundaries. I always allocate alternate tracks. Not really important for VM370, but I know MVS 3.8 is sensitive to that. So just out of habit, I always use -A to allocate the alternate tracks. We're going to make the file called vmrel6.3330, which is a 3330 volume, and we'll label it vmrel6. Similarly, we'll DASD in it the CPR6L0.3330 as a 3330 labeled CPR6L0. I don't use CCKDs, the compressed DASD files, because I don't need compression because I'm using a file system that has native compression, and I don't need the shadow file support because I'm using a file system that supports its own point-in-time atomic snapshots. So if you do use CCKDs, I think you would just pass in like the -Z flag to use gzip compression. And then there might be a type flag for CCKD instead of plain CKD, but I'll leave that as an exercise to the reader. I recommend using file systems that support those features and then just using uncompressed large file DASD. Okay, what do we have at this point? We have our DASD, we have our Hercules config file, we have our tapes. Now we're really ready to go. So let's start up Hercules. And I'm just going to quickly make sure I don't see any obvious errors. I don't. If you hit escape, we can see the graphical view of our hardware. So again, we have our console, reader, punch, printer, 2 DASDs, tape drive starting at 280, 3270s. So it looks like everything worked. No errors in our config file. That is excellent. I'll label this tmux pane. I kind of already was because it's the running program, but I'll just permanently label it Hercules so that we know this is our Hercules interface. Let's make a new terminal. This one is going to be console. This is the VM370 console. So we'll tell it to port 3270, which is the Hercules default. We didn't give it a different port. So here we are. Yeah, we're successfully connected to Hercules. We like to see that. We'll probably also want just a shell. So I'll leave this pane running. We'll name it shell. We're going to need to go out and edit some files at some point. So we'll do that. And last but not least, let's label this one virtual 1403. This is where we'll leave virtual 1403 running. So this can just run in the background here. It will spit out anything we print into this PDFs directory, and it's successfully connected to Hercules. And we're going to be starting and stopping Hercules, but don't worry, virtual 1403 will just keep retrying to connect if it loses its connection. So with that, let's go back to the instructions. Okay, step one, we need to IPL from that starter system tape. So let's do that. That's going to be over in Hercules. We dev init 280 was our first tape drive, the starter tape. So that loads the tape, and then we can IPL from device 280. Okay, if we go over to our console, so far so good. We got something. So this is the VM370 format allocate program. And this is the program we can use to format disks and then allocate space for the different types of space on disk that VM370 uses. So if we go over to our instructions, we'll go to step 2. It will have us format, label, and allocate the system residence volume. So this is our new VM 6 volume that we have at address 131. So it tells us we're going to run the format command on 131. Our device type is going to be a 3330. And we are going to format from cylinder 0 through end cylinder, whatever the end cylinder of our disk is. And then we're going to label it VM 6 and format. So it gives us a helpful footnote here, footnote 1. And it tells us that a 3330, the last cylinder number is 403. So yeah, it's a 404 cylinder disk, so 0 to 403. So if we switch back over to our mainframe console, we can do that now. So we want to format 131, which is a 3330 device type, from cylinder 0 to cylinder 403, and we're going to label it VM 6. So format started, format done. 0 errors, which is what I'd sure hope for in our virtual DASD. So that's done. What's next? Okay, so now we need to allocate. So we need to build the allocation table that allocates some permanent space, directory space, temp space, and tdisk space on the disk. So it has the different allocations it expects for the different device types. So we are using a 3330. And so we're just going to follow this table exactly for our space allocations. So you will want to note that down and switch back over to the console. This time we're going to allocate device 131, which is a 3330. And it's going to verify the labels so that we're working on the disk that we think we're working on. So VM 6 again. And then just enter the allocations as they were shown in that table. So that was perm from 000 to 012, and then directory space from 013 to 016, temp space from 017 to 201, more perm space from 202 to 202, so there's one cylinder there, more temp space from 203 to 389, and then tdisk space from 390 to 402. And then you just type end when you're done. and it will spit back out that here's the allocation table it made. So a lot of the space is where, for example, the saved segments, the CMS saved segment, the actual CMS saved system, that's going to end up going in some of the space that was allocated on our new system residence volume, along with the space that we have for, of course, the new CP nucleus itself, those kinds of things. So then we go on to step 3, which is to label the starter system volume. So we're not going to format or put an allocation table on the starter system value because we're just going to restore the starter system from tape to this volume. So it just wants to make sure that it's labeled CPR6L0, and then the rest of the data will just overwrite whatever's on the disk from that tape. So we're going to format 130 with the label CPR6L0. We can do that over here. So format 130, which is a 3330, and then we're going to label it CPR6L0. Okay, label is now CPR6L0. Step 4. So next we need to IPL the starter system tape a second time. So the next program on the tape where it's currently positioned is the DASD dump restore program. So we'll go back to Hercules, which is over in this pane. We're going to say stop. Hercules won't let us run the IPL command if any processors are currently running. And then without rewinding the tape or anything, we're just going to IPL from that tape again. Okay, looks like that worked. So it just picked up right where we left off, and it printed VM370 DASD dump restore program. And so we enter control statements for the DASD dump restore program. So let's see what we need to enter here. So you can enter the sysprint thing if you want to say it should print the dump devices. I think it actually defaults to 00E, which is kind of, again, a default address for a printer. So we're going to tell it input from the tape at device address 280. And our tape is a 3420, not a 2400, so we'll need to remember that. And then output to the DASD at 130. That's going to be a 3330 with the label CPR6L0, and then restore all. So we can say input 280, which is a 3420 tape, output to 130, which is a 3330 DASD with the label CPR6L0, and then restore all. Okay, so I've run into this with this version of the DDR program. It says invalid input or output definition. I don't know what it thought was invalid, but if you just copy and paste the same two commands, input, output, or I guess the same three commands, restore all, it works. So some little glitch somewhere. So yeah, restoring CPR6L0. We're supposed to get a restore complete message if we look back at the end of restore. Instead, we get this intervention required on our tape drive. I don't know if this is just because it's a different tape drive model, so it sends a different interrupt when it hits the end of tape here, or if this is just some quirk in how Hercules emulates the control unit versus how it worked in the real world. Regardless, don't let this message worry you. The restore was successful, and we have a complete copy of the starter system on CPR6L0 now. So the instructions tell us that we can enter a null line to get to the end of job, but in our case, we're just going to shut the system down. So it tells us, here's the layout. Let's see, we restored the 3330. So here's the layout of what we restored. We have a CP nucleus. We have areas for some mini disks for the CP gen user, which is going to be the user in the starter system that we do the actual system generation from. So if you're interested in that, that's the whole layout. And if we scroll down past all of that, right, so the next step here is to IPL the starter system. So we need to IPL from that 130 volume. I'm going to switch back over here. And let's go to Hercules. I'm going to quit Hercules I have found that things tend to be more reliable if you actually restart Hercules between IPLs. We'll just get completely fresh state of everything. So we'll go to Hercules. We'll reconnect our typewriter terminal printer, typewriter printer terminal. So just telnet to localhost. And then if we go back over to Hercules, now we can IPL from that starter system that we restored. So that's on our 130 DASD. Okay, good news. So it looks like that starter system did restore. We're now at the prompt for VM370 starter system release 6. Now, normally the device addresses and everything for the real IO, you write with some assembler macros, and that actually gets assembled and built into the VM370 control program, the CP nucleus. But the starter system kind of has a special IPL process where it's going to ask us for some device addresses and types so that it can build its real IO config on the fly, just enough devices for us to do the system generation. So our printer address, 00E, it is a 1403. And our punch address, that's 00D, that's a 3525 punch. Our reader is at 00C, it's a 3505. The PID tape, so again, that's the PTF tape or the program update tape. Every time you see it, they call it something different. PID is the program information division or program information department at IBM. So they're the ones who would have sent you that tape. That's going to be on the tape drive at address 280. And that's a 3420 tape drive. And our scratch tape. So we're going to have another tape, just a blank tape on 281, which is also a 3420. And then our new system residence volume, that's going to be at 131, and it is a 3330. So we can confirm all of those are correct. They look correct to me, so I'll type yes. All right, so now this is the normal VM370 IPL process. And you can see here, sure enough, this is February 27th, 1979. So we are using an operating system release here that was packaged up in early 1979. Amazingly enough, this is actually correct. So it appears to understand how to still calculate the calendar in the year 2025 because February 7th is indeed a Friday. And it looks like it's defaulting to Eastern Daylight Time, which is incorrect. But if I do the math to apply that offset, that is actually the correct time. So we do not need to change the time of day clock. And we do a cold start here. Okay, here we are. So if we look in the instructions, we've IPL'd, we defined all those devices, we did the cold start, and we are sitting at basically just a new, fresh CP prompt here. Okay, so set the terminal mode. If the system console is a display device, so that'd be like a 3270, you can spool the console so you can get a printout later if you need to look at what you did. I'm already using a printer or typewriter terminal, so I don't need to worry about spooling. We're going to have a record in our telnet session here of everything we did. And because I'm in Tmux, I can scroll back up in its own history buffer. But we do need to set terminal mode VM. So I'm going to hit enter, make sure I have a prompt. Yep, so terminal mode VM. And then I have to hit enter a couple of times. Okay, so now, yeah, we're getting the CP prompt again. And then we need to define or attach the system residence device. So we can query virtual DASD, and you can see our new system residence volume is currently at virtual address 350. That needs to end up at address 131, virtual address 131. It's already real address 131, but it came into this CP Gen VM at 350. So we can confirm here if we're using a starter system type of 330, which we are, and a system residence device type of 330, we do expect it to be at 350 there. So it looks like all that worked as expected. And then we just go define 350 as 131. So define 350 as 131. Okay, there we go. Now if we query virtual DASD, you'll see that it has reassigned the, where'd it go? There it is. It has reassigned the VMRel 6 volume to virtual address 131. So step 10, we need to make the tape drives available. Also, okay, yeah, before I forget, I'm going to mount the tapes and the tape drives because I will forget to actually do that, and we'll run commands that start reading from tape, and there won't be any tape there. So let's do this. So attach, so again, real tape drive address 281 to CPGen as virtual address 181, and then attach 281 to CPGen as 182. We can also set our dump device to our printer. So let's do all of that. Attach 280 to CPGen as 181, and then attach 281 to CPGen as 182. And was it set dump? Yeah, set dump 00E. Now, as I mentioned, before I forget, we need that scratch tape. So let me go to my shell here, and the het init command will make a new tape. So I can say het init, and I can just go, this is just going to be scratch, and we'll give it a label. I think that's how many letters I get, SCRTCH. So yeah, as always, drop vowels in typical word shortening fashion. And then back at the Hercules prompt, we'll devinit 280 with that PTF tape, and then we'll devinit 281 with our scratch tape. So with that out of the way, I don't need to worry about forgetting to mount those tapes. Okay, what next? Yeah, so it's reminding us here that the 280 should be wherever we told it the starter system tape. I think it actually said where the PID tape, not the starter system tape is, but we get the idea. And the scratch tape. Okay. Now we can IPL the version of CMS that comes on the starter system. There are no named saved systems yet and no saved segments. So we're going to use just the device number. So minidisk 190 for maint has CMS on it. And we're going to give it the parameter seg equals null so it doesn't try and load a saved segment that we haven't saved yet. So IPL 190 parm seg equal null. And that goes back in our console here. So IPL 190 parm seg equals null. So here we have an even older CMS, CMS release 6 from December 25th. Somebody working on Christmas at IBM, 1978. So just hit enter there at the CMS IPL prompt. And as you can see, CMS seg name null, which is nothing. All right, define and format a temporary mini disk. So we're going to define T3330 at virtual address 192. And because we're on a 3330, it needs to be 11 cylinders. So define T3330, 192.11. Define T3330, 192.11. Okay, it gave us a new DASD out of the temporary space. So this is a temporary mini disk of 11 cylinders. And I'm guessing we need to format it. Yep, so format it at file mode D. Format 192D. Yes, we want to continue. And we can just call it temp 192. The name really doesn't matter. And last step, we need to obtain write access to our CMS system disk. Okay, so right now, the 190 disk, I believe, always comes in as disk. That's the S disk, I think, by default. read only. So we're just going to relink to the CMS system disk 190 as 190 with write access using the right password write. So link CMS sys 190 190 write, and the right password is write. All right, what's next? So we're going to apply some initial service before we build our CP nucleus. And that'll come from that system put tape that we mounted in step 10. And as it says, it'll contain all the new updates as well as all previous updates since the latest base release. The program information department automatically ships it, blah, 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 blah. So rather than doing this on the actual CP Gen 191 disk, we're going to copy everything from our 191 disk over to that new temporary disk we made. And then it looks like we're going to load the PTF materials from the tape into that temporary disk. So that will be copy all files on disk A to the same name on disk D. So now we can actually say list ** D. Okay, so it looks like just a couple of assembly input files, a sample directory, and then some kind of listing. Perfect. So we'll use the CMS tape archive program. So that's VMFPLC2. And it was load everything to D. There we go. So we got our VM service exec, and then 5749010 is the program number for either VM370 as a whole at this time or for CP. And then this is going to be the level, the release level of the PTFs. Okay, so we've done that. And yep, that looks like the files we expected. So now we need to access our 192 disk as C, and then we're going to release A. And we can do that. Access 192C, release A. And then we run that VM serve program that just came in from tape. And this is the VM service program. So VM serve. Okay, so it looks like it loaded some more stuff from tape. I think we got to the end of the tape there. And yep, rewind complete. So it's telling us we should review the memos to user prior to installing service. Would you like to print the memos to user? Yes, this is very, very important information, as you will see later in the process. It printed out that memo to user, and we're now just back at the CMS prompt. So let's look. If we look at that virtual 1303 terminal here, sure enough, it received a print job and it wrote 139 pages of PDF to PDFs that. So let's go to our, what's the best way to read this? Let's go to our web browser. And we can just open, let's see, virtual 1403, PDFs. Yep, so it'll be the big one, not the small one. I mean, big is relative. It's less than 200K still. But, you know, we got 139 pages of output here. Okay. So this is, let me zoom in a little bit for purposes of the video here. This is the VM370 Release 6 system put. So this first document is the documentation for this tape overall. It talks about the update. It talks about what is on the tape. So it'll have various tape files for the various programs that it can update. Here's the layout of the tape. And it actually gives us documentation for that VM serve command we just used. This is going to be helpful later in the process. So yeah, that's the documentation for VM serve itself. And this is just information about the update tape. Now, if we scroll past this document, the next file it prints is going to be, I have a little glossary here. Yeah, PID, program level change, program product, all of the IBM acronyms. Okay, forging ahead. If you keep scrolling, we'll get another job or another file that printed out at the same time here. And this is the memo to users for this program update. So this is where they'll include any information about what you need to know if you're upgrading, if you're applying these patches to your system. I'm going to scroll ahead to note 13 because this is what is relevant to us for installing a new system. We're going to need to make sure that we have these mini disks at least this big, these numbers of cylinders large for the update to work properly. Some of these mini disks won't even exist yet in the sample directory that we're going to start with. And the 194 mini disk we'll see actually needs to be increased in size to 30 cylinders. So it will talk about that here. And then it mentions that when we are on step 20 of our installation guide here, so what are we on now? We're on step 13. So we'll need to remember to come back at step 20 to make sure that we define these areas as appropriate. I guess step 15 is when we'll put them in our directory. And then step 22, we'll need to remember to format the new mini disks in addition to the ones that the instructions are going to have us format. And it's going to have us make a temporary 494 mini disk. This is what we're going to create so that we can copy everything from the existing 194 over to this bigger mini disk. And then we'll reallocate our new 494 as 194. So this will make sense when we go through it, but they just have some helpful notes here to remind us, okay, when you get to step 15, remember, when you get to step 22, remember. So that's kind of convenient because it just will match up with the steps as we encounter them in our directions here. So that's about it. That's really the only critical note is this note 13 here. If you're interested in the rest of it, you can read that on your own time. I won't make everyone here in the video sit around while we read through 139 pages of printer output. Now that we have done that, if you invoke the vmserve program with no memo, that will skip what we just did in terms of printing the memo, and then it will actually do the work. So it looks like we want vmserve no memo and no IPL. And then that will start applying the service. So let's go back over there and do that. vmserve, back to our console, vmserve, no memo, no IPL. Do you wish to apply service for this product? Yes, we do. Do you wish VM370 CP service? Yes, we do. 194 is the staging area for the service. And yes, this is the initial sysgen of the system. We are running on the starter system. So again, it knows how to do things just to get this initial starter system generation going with some service. Okay, so it's doing whatever it does. That'll just take another second here. Perfect. Status of CP service loaded. So obtain write access to your CMS system disk. We already did that, I believe. That's when we relinked that 190 volume with write access. And then if you're using a starter system, just press enter here. So I'm going to hit enter. All right. So it looks like that service was loaded. And then it re-IPL'd the CMS system disk due to CMS disk changes. Okay, so we'll just hit enter again at the CMS prompt. Looks good. Okay, so after CMS re-IPLs, we need to re-access that temp disk that we made. So remember, we're still logged into the same CPGen VM. It's only CMS that re-IPL'd, and it's CMS that needs to access that mini disk. So access 192A will bring that temp disk back, this time as file mode A. Access 192A. Perfect. So now prepare the service programs. So if we run this generate service program command, that's going to punch a number of standalone utilities to the card reader. Now, these aren't actually going to work because we have our card reader set to translate to ASCII, and because these are just essentially binary program text decks, the translation to and from ASCII and EBCDIC, something will be lost in translation there. So these won't actually be bootable, but we just need to punch them because what we actually want punched will happen immediately in the same uh, generate service program step, which are the sample decks for the directory, DMKSNT, DMKSYS. So we'll just essentially throw away and ignore these standalone programs, which is all a long way of saying just run the command the manual tells you to. Generate SRVC program. Generate SRVC program. So that punched those. Do we want to print a copy of the directory? No, because we're going to punch it. So we'll say yes to punch all of these samples. And that's all done. So I don't know why that was separated into step 14 and 15, because it really felt like the same step there. Now, step 16. This is where things get interesting. So what we need to do is load up in our card reader the initial directory that we're going to want to use on our new system, the DMK RIO configuration macros. So this is where we tell the system these are the devices at these real device addresses. The DMK sys macros, this defines the system. And then the system name table macros. This is where we lay out things like where on disk should we be able to save a system named CMS, so that if somebody says IPL CMS, they get a saved image of storage that is kind of already IPL'd instead of having to always execute the initial IPL steps, which back when mainframes were slow and disks were slow, probably saved some time. So we need to build up a text file simulating a stack of punched cards with all of this in it. So it's going to have an ID card to direct the data to the CPGen user. And then we have these read directives to say, read the following content to this file name, then read the following content to this other file name, so on and so forth. So we'll leave this here for the moment, and let's go back to the terminal. If we go out to the shell here, you can see that our card punch output, sure enough, is filled up with a whole stack of cards. Can you imagine how many cards 147K worth of data would have been if this was a real card punch output? In fact, yeah, so just during this process already, it has punched nearly 2,000 cards that would just be sitting there in our card punch output. This was wild back when we were really using punched cards for all of this kind of stuff. In any case, if we look at that file, and I'm just going to go up to the top here, as you can see, it's pretty messy. That's actually even a little more messy than I was expecting. But if we get down to the bottom, yeah, so here's the nice cleaner output of the actual samples of those configuration files, the configuration decks that we need to make. All the stuff up here was the actual, like the binary, those actual IPL-able programs. So here's where what we want starts. So I'm going to just grab all of this down to the bottom of the file. So I'll do Y for yank, and then capital G is end of file. So that's 557 lines yanked. Let's edit a new file. We'll just call it cards.txt maybe. Sure. And then I'll hit P to put. And that carried over what I yanked from the other file. So the first card needs to be ID CPGen. And then we're going to have these read cards that tell us what files we want these read into. So we have that SNT, the system name table. And it sort of has, yeah, so it has some documentation in the comments here. And then for this one, I think all of the defaults just from the sample deck should be correct. And again, because we're using the 3330 starter system and we're going to use a 3330 system residence volume, these examples are correct. And this is one of the reasons that just doing 3330 to 3330 is more convenient. There are examples for the other DASD types in the Sysgen manual, but then you'd sort of have to mix and match from what you're using because the starter system remains 3330, even if we were doing a 3350 system residence volume. So, like I said, we're keeping it easy by just using 3330s for everything at this point. So that all looks good. We used the recommended name, so that default is correct. We used the name of the starter volume, and all of these cylinders are going to match the layout of the appropriate places on that starter system disk, as well as the appropriate places on our system residence volume. So we'll just scroll down past all of these because that whole thing is correct. Get rid of these separator cards. Get rid of that separator card. And the next one here is the DMK sys. So we'll just clean up that line. We don't need that extra info. And again, this will be the DMK sys for a 3330 system. And the sys own. So again, the format for all of these is in this this guide that we're in. Higher up, before we got to the actual steps, it did explain the format for all of these configuration macros. But we have what we need here in the examples. So sys own, these are the volumes owned by CP. So if you have a volume that's just going to be mini disks, it doesn't need to be owned by CP. But if you have a volume that you want to use for directory space, temporary disk space, or other temp space, such as the paging areas and the spool areas, those need to be the system-owned volumes. So those actually need to be assembled here into a module that's built into the CP nucleus. So this is saying VMRel 6 is going to be system-owned, and then this temp parameter means that I think it will prefer this for, I think, temp space over page space, or temp space over spool space, one or the other. Again, you'd have to go back and check the documentation. But it doesn't matter when we only have one volume because it's just going to use this volume for everything. But if you have multiple system-owned volumes, this is how you can start controlling where you want to prefer to use for paging space if needed versus some of the other temporary needs. Sysres, this is all correct. VMRel 6 at address 131 is a 3330. This is going to be the correct layout for the cylinders on that disk. One thing we will change here, core memory, real memory size. This will limit this CP nucleus to using 512K of real memory of storage. But we paid for 16 megabytes. So we're going to change this to 16 megabytes, the maximum VM370 can use. Make sure that you don't end up with that first zero in the continuation column because we're one character short here. So just, again, make sure that this all stays aligned correctly. You can make RM size larger, again, up to 16 megs, but you can make it larger than your real storage. It's just that the CP that you then IPL will be using more of your lower amount of storage than it needs to keep its whole memory map for potentially the full 16 megabytes. So you wouldn't want to really make this a lot bigger if you didn't really have this much storage in your mainframe. But we do have 16 megs, so we are going to say 16 megs there. And then you just have options here for who your operator user is. This user is going to be logged in automatically at IPL. Oh, and here's where we can change that time zone. So I am currently 8 hours west, and we are on Pacific Standard Time. So that's it for DMK sys. Again, get rid of any blank cards, get rid of any separator cards. So this is the forms control buffer. We don't need this at all. So let's just highlight all of this and delete it. I think it's actually quite a bit of stuff here. So just go until you see those separator cards again. Here we go. Yep. So we'll delete all the way up to the directory. Perfect. That's what we need. So release 6 direct. So this will be our directory. We do need to make a couple of modifications here. We're going to use device 131. So this is where the direct program is going to actually build and load the directory. And that's VMRel 6. Note that this is a virtual address in whatever VM you're running the directory program from. So we'll see later that for the maint user, we will define a 131 full pack mini disk that covers the entire real VMRel 6 volume. Operator, we can leave at the defaults. CE, what's that? Customer engineering, we can leave at the defaults. Maint user. Now, are you having flashbacks to that important note we read in the memo to users? We're going to need to modify the maint user here to add some mini disks so that we can successfully apply the rest of the service. And then this is where we change to 131 and VMRel 6. So this is going to be that full pack mini disk. This mini disk 131 covers the entire VMRel 6 volume from cylinder 0 to 404. So anytime we need to operate on the actual real full disk, we'll have access to do so through mini disk 131. And as it says, the above entry should be modified to match whatever your system residence volume is. IVP, that's the installation verification program. There's a couple users for that. We can leave defaults. RSCS, remote spooling communication system. So that has its own mini disks and its own VM setup. EC mode and operate NS. This has something to do with where some system dumps go. But again, we can leave all that default. We're not going to set up IPCS or anything at this point, so I'm just going to leave this as is commented out. And it's also good to note here that on the layout of the starter system disk, cylinders 142 to 403 will remain unused. So when we make these new mini disks for maint that we need to make, we can start them at cylinder 142, and then we have until the end of the disk. So let's go back up to maint, and we're going to need to figure out what we want to do here. Okay, so here's maint. And I need to get out a piece of paper here. Okay. Because I'm just going to write some notes off to the side while we do this. So maint currently has a 190, a 191, a 194, and a 199. Now, if we look back at the memo to users, we need our maint to have a 190, which we have, a 191, which we have, and actually, I didn't write down the other important bit here, which is 190 is currently 85 cylinders. 191 is 7 cylinders. 194 is 27 cylinders. And then 199 is 1 cylinder. So this isn't cylinder start, cylinder stop. This is cylinder start and then number of cylinders. So starting at cylinder 30 on the disk CPR6L0, we go for 85 cylinders. Starting at cylinder 17 on disk CPR6L0, we go for 7 cylinders. So as we look here, our 190 disk, it needs to be a minimum of 60. We have an 85, so that's good. 191 needs to be a minimum of 7. We already have 7, so that's fine. 193 doesn't exist at all, so we need to create a 193 of at least 6 cylinders. 393 and 394, these are optional source disks. I'm not going to worry about trying to load the source right now. I did note on that CBT tape site, there is a base source tape here. Now, when the guide talks about the source tapes, it makes it sound like the CP source and the CMS source would have been on different tapes. I'm not sure how to load these to the source areas. I don't know if you would need to do that before you apply the service, because the service also updates the source as necessary. So again, to keep things simple and moving forward here, we're not going to worry about the source volumes because they're optional. So we don't have a 393, but that's fine. We don't have a 394, but that's fine. So 194, we do have a 194, but it's not big enough. It's only 27 cylinders. So hence the note down below about showing us how to move the content currently on disk 194 to a new larger disk, which we're going to temporarily place at address 494. And then we also need a 294 that is 12 cylinders. 294 does not yet exist. So we're going to need to allocate a 294 disk that is at least 12 cylinders. So we can do that. Let's go back and look at the directory. So as I said, we have 190, it's big enough. We have 191, it's big enough. We need a 193. So let's make an mdisk 193 3330. And where did we say the free space begins? The free space begins at cylinder 142. So we'll start that new 193 mini disk at cylinder 142. Let's find mate again here. Here we go. So 142. I was going to say 192, but no, it's the 193 mini disk. Starts at cylinder 142. And this needs to be 6. Let's be generous and give it 10 cylinders in case there's future updates that need even more space. And then 193, I think, can just be a write and read access. We can give it a read password of read, I guess. So that's 193. So then the next one we need was 194. Now, again, we know that 194 is not big enough. So I'm going to make a new temporary 494, as the memo suggests. We'll just start this after the 193. So if we went 142 for 10 cylinders, that means we're using cylinders 142 through 152. So we should be able to start at cylinder 153. And how big did we say 194 needed to be? It needed to be at least 30. So again, let's be generous. We'll give it 35 cylinders on CPR6L0. And it looks like 194 is a multiple access disk. So we'll do MR and set the read password to read. Again, not great passwords, but you know how it goes. Okay, so that is going to be our new... I'm just writing this down as I go so I can refer to it later. So 494 starts at 153 for 35 cylinders. Okay, what else do we need? We got 191, 193, 194. We need a 294 disk. So that doesn't exist at all. So let me put that right in here. So 294 is a 3330. And again, we'll pick up where we left off after the space we allocated for 494. So what's that? So 153 plus 35 should be 188. And then we need to go one cylinder beyond that. So 189 is where our 294 will start. So 189, and that needed to be at least 12 cylinders. We'll give it 15 on CPR6L0. And give that a read password as well in case somebody needs to link to it. So I think that's everything. We have the existing 190 disk. We have Mainten's 191 disk, which we're going to need to format later. We have our new 494 disk. which of course we'll need to format, move all the 194 content over to, and then change into 194. 199, we don't know what that's about. That's just out there, so we won't worry about that. And then we have our new 193, and we have our new 294. So does that look correct to everyone? I'm sure if it's not, you're sitting there thinking, I can't believe you're not noticing what you did wrong. But since I can't hear you right now, we'll just forge ahead. Okay, so the directory, that was the last thing that got punched out. So back to the top here. Let me just save that as we go here. So let's go back to the instructions and the actual Sysgen guide. So it's telling us place the following cards in the card reader in the sequence shown. So these are just all going to get read into files before any work tries to get done. But because they tell us in the sequence shown, I'm going to be careful to follow the directions here. So the directory needs to be the first thing in the file or in the card deck. So let's go back to release 6 direct. Yeah, so let's grab the entire directory and we'll put that right up at the beginning of the stack, just below the ID card. Perfect. And then next we needed, the DMK RIO symbol. There was no sample of the DMK RIO. So let's just put a placeholder there. So read DMK RIO symbol. And that's going to be read. Yeah, so right after the directory, we need a DMK RIO symbol. Padding out the full potential file name with spaces isn't critical, but you do need 2 spaces after this little read command. And we're going to need something here. We're not sure yet, but let's just finish getting these in the right order. So after DMK RIO symbol, we need DMK sys symbol. So let's go to DMK sys. Here it is. We'll grab all of this and we'll put that right after our DMK RIO. And then that leaves DMK S&T as the last set of cards in the stack. So make sure we don't have any empty cards. Everything's either a comment or content. They're in the right order. We got rid of all those extra separator cards that got punched out. Yep. Okay. So all we need to do now is fill in whatever this DMK RIO is. So let me set auto indent because pretty much all these lines are going to be indented to the same level. If we go to the instructions, let me make a note of what page we're on here. We're on page 274. Perfect. Up on page, let me look at my little bookmarks for this PDF file. Page 159. Yep, here we are. So page 159, preparing the real IO configuration file, DMK RIO. So we're not going to have any remote display stations. All our 3270s are locally attached, so we don't need to worry about that. What we do need to worry about is an R device macro for every address that we want to be able to put a device on. And then we need control units and channels to cover whatever those addresses may be. And then we finish off with the RIO gen macro, which will take a parameter that tells us where the system console is. So this section of the manual will walk you through all of the devices that are supported and all of the options on all of those devices. And then if you go all the way to the bottom of it, we go ahead several. So here's all of the device types that are supported. If we keep going forward, they will show us a sample mainframe hardware configuration, a little graphical schematic view of it, and then they show us the DMK RIO macros to define that system. So if you're building this up and you want to build it up with all of the hardware that you want on your Hercules mainframe, you can go through here and see what the required and optional parameters are for each of the different device types and how all of this works. So I've done a little bit of this planning ahead of time, and we can go through and just build up the DMK RIO macros for that small, kind of minimal Hercules system that we are running on right now. So let's go back over to our editor here, and this is where we will start typing in our DMK RIO stuff. So this is all under a C sect. And then remember, you're going to need an end directive at the end of this. So I'm going to put that in now because I won't remember after typing all of this stuff in. So we're going to do an R device macro for every device that we want on our system. So we need to give it the address. We're going to start with our terminal, and that's a dev type of 3215. So in my generated system, I'm going to continue using a 3215 as the system console. I'll use the 3270s for all of my actual usage. All of my user usage will be on the 3270s. But for VM370 in particular, I find it most convenient just to have a rolling system console on the typewriter keyboard. What's the word I'm looking for? Console device. That said, VM370 does support 3270s as the system console, so you could use the 3270 if you wanted to here for the system console. We also need an R device, and I'm just going to copy that because we're going to type this a number of times. We'll fill out our unit record devices here. So at address C is our 3505 card reader. D is going to be our 3525 card punch. Now, output devices need to be assigned to the classes, the output classes that they handle. So I'm going to assume we have maybe this X class for system programmer use, and then the general default output class is A. So class X and A output will go to this 00D device. Same thing with our printer. That's going to be a 1403 serving classes X and A. And then on the printer, we can give it the feature universal character set. So if you remember from our Hercules config, the next thing we wanted was a block of 16 addresses where we can put 3330 DASD. So you can use this syntax here where you say a starting address and then the number of devices from this address forward. So this will quickly define 130 through 13F. And again, that'll be a dev type of 3330. And we need to give this a model parameter. So there's a 3330 model 1, which is 404 cylinders. 3330 model 11s were twice as big at 808 cylinders. Same deal, we'll put that space for our future 3350 DASDs. 3350, there were not multiple models of 3350s, so there's no model parameter there. And next up are our tape drives. So 280, I think we said we had, did we give ourselves 8 tape drives? That's going to be a 3420 tape drive, dual density, model 7. And then our 3270 terminals, we had starting at 320. We'll do 8 of those. And these are going to be 3277s. And I think that's it for our hardware. So again, if you wanted to do more with this system, if you wanted to have a bunch more DASD slots because you were going to put all of the MVS 3.8 disks under it, if you wanted more than 16 3350s for just mini disk space, if you wanted to play with RSCS to do remote job entry and network job entry, you would need to have some channel-to-channel adapters defined here. So again, depending on what you want to use the system for, go back and look in the Sysgen guide to see exactly how you define the device types that you're interested in, and then just add them to your real IO config here. But this is all we need for our purposes. So now we need the control units covering whatever addresses we have devices on. Control units typically cover 8 or 16 addresses, and those would typically be covering space that is divisible by 6. So, for example, the control unit covering our unit record devices here would start at address 8. So that's going to be a real control unit. And then it has an address of 008. And then it has a control unit type. And we're going to use a control unit 2821 control unit for our unit record devices. And then I'll just copy this because, again, we're going to use that a lot. So next we need a control unit that covers these 16 DASDs. So that's going to start at address 130. That's divisible by 8, so that works. And the type here for DASDs is going to be a 3830 controller. And it comes in a 16 device variety. So that's going to cover our addresses 130 through 13F. Similarly, for 150, it's the same controller for 3350s. Those hooked up to 3830 controllers as well. And we can make the 16 device variety there. We're going to need a controller covering our tape drives. So starting at 280, the tape control unit is a 3808. And we are happy with 8 devices there, so that's fine. And then similarly, the control unit for our locally attached 3270 terminals is a 3272 controller. And that will cover our 8 3277s there. So now that we have control units covering all of our device addresses, we need the channels defined. So channel address 0, the multiplexer type here, or the channel type here, is going to be multiplexer. That's pretty typical for the unit record devices. And then our channel address 1 will cover everything in the 100 series of devices. And that's going to be a block multiplexer, which is BLK-MPXR. 2, same thing, block multiplexer. And then we'll just go ahead and make 3 a block multiplexer as well. These control unit types and multiplexers don't really matter for Hercules. It just sort of emulates the right control unit on the individual channel as part of the device it's emulating. But we need to put them in here, and they need to be somewhat reasonable because these R device macros will actually expand to reference names that are generated in the expansion of these control unit macros, which will in turn expand and reference names that are generated in the channel. And I just noticed my mistake here. That should be our channel. So this all needs to be laid out correctly in what you're doing here. I'll get rid of that highlighting. Okay, so that all looks correct. And then the last statement we need was that RIO gen. And here we're just going to tell it that our console is at address 009. So that's where our console will be when we IPL the system. Now, if you make a mistake in any of this, everything in this card deck, it's not the end of the world. The generation process will try and assemble these. If there's a critical error, it'll abort out and it will tell you to just reload that broken file in the reader, and then you can pick up where you left off. It'll actually tell you the command to run to pick back up at whatever step in the process it broke. If there are just assembler notes or warnings that don't completely break the assembly, then it will just continue going on. So something like if you forget the end statement here, it'll actually work. You'll just get an assembler note that said it's missing an end statement. So if you make a mistake that only generates a note and you realize you actually want to fix that mistake, you just sort of redo the whole process you're about to see. Just load the whole card deck again and then rerun the generate VM370 command. Okay, so that took a while, but again, that's, getting these card decks all arranged, correct, put together. this really is the input to the generation process. And while this overall process you can really think of more as the installation of this new system, what we're about to do is the real Sysgen, where we are assembling those decks, turning them into modules, and then linking them together into the CP nucleus. That's the generation of the VM370 system. So exciting times. We're almost there. So let's go back to the instructions. And let's see. I wrote this down, didn't I? Yes, we were on page 274. Okay, so place the following cards in your card reader in the sequence shown. So I'm going to go to Hercules. And we will devon it. The card reader is 00C, and we called that cards.text. Perfect. Go back to our console here. And if we look at the instructions, we've done that. So optionally, we can have that form control buffer stuff in there. But like I said, we're not going to worry about that. This is just telling us how that :read space file name thing works. We are not using only one tape drive, so we're not going to run this command. We still have our scratch tape mounted on the real tape device 281, which we have in our VM as 182. Okay, so we invoke the generate exec. So generate VM370. Let's do that. Generate VM370. Okay, so it read in all of those files. That looks good. And then it's asking the directory file name. So we called that release 6 direct. Note that it read these in to the 194 disk. So after we're in our newly generated system and we IPL, we'll still have access to this directory that we made. So we can just edit it to update it. So that'll be convenient. Okay, so that's the directory. The directory's been built. It's assembling these files. Good. No statements flagged. No statements flagged. No statements flagged. It looks like we didn't make any too grievous of mistakes in those text input decks. Or I should say those assembly input decks that create program text. Okay, are you generating an AP system? That's an attached processor system. That's if you have two processors. No, we are not. Do we need a virtual equals real area? No, we do not. Okay, so this is a normal error file DMK SLC not found. That's the module for a either an attached processor system or a virtual equals real system. So that's fine. So complete. IP table now on tape. So it wrote the IPLable nucleus to that tape. So I guess if all else fails, we can IPL from that scratch tape. And it gives us some information here. The instruction manual is actually going to repeat that, so we don't need to remember that for now. And then it says nucleus loaded on VMRel 6. And then it just doesn't do anything. So let's see if that's what we expect. Okay. So we said no to those questions. Yeah, so if you respond no to this message, that error, the file not found, is normal. Okay, load the CP nucleus. No errors were detected, so we don't need to do that. This is the text it printed out. That's fine. Okay, so this is what we did. We're loading a CP nucleus without a virtual equal real area. So sure enough, it said nucleus loaded on vol ID. Okay, the CP map is placed after your new system is operational. You can do this. Okay. So I guess, so are we still in, again, we're not going to worry about trying to make IPCS work for now, but it sounds like if we ever do, we will want the load map of our nucleus available to us. So let's go back to our console here and we'll say, yeah, okay, we are still in CP here. So we can close the printer. And then we IPL CMS again. So IPL 190 parm seg equals null. We're going to access 194 as A. And then we can read CP IPCS map A. Read CP IPCS map A. Very good. Okay. Yeah, so this has now saved our new CP nucleus map to our 194 disk, which is persistent. This data will continue to live on, and it looks like it successfully read that in. So after we've done that, we are going to shut down the starter system. So drain all and then shut down. Drain all, shut down. System shutdown complete. Great. So let's quit Hercules to really turn our mainframe off. Now, this would be a very good time to back up your newly generated system. There's still some additional service to be applied, and we'll see that we're going to go a little bit off script here from the manual. So if you ever want to redo this process, right now your system just consists of these two DASD disks. So obviously you can do shadow files, you can take a snapshot. I'm just going to keep them around so I can easily use them later for other purposes. So I'm just going to create a new tar file here. So this is going to be, I'll call it mid generation.tgz. And then I'm just going to include the CPR6L0 and the VMRL6 DASD files there. Okay. So if you are building with a virtual equal real area, it looks like there's some slightly different text and directions here, but we don't need to worry about that. Next, step 19, we IPL the newly generated VM370. So if you plan to keep the CPR6L0 volume as allocated when using the various system directories, we need to reallocate the space on it. So we are going to keep CPR6L0, and it's important to understand what has happened here. We restored that starter system tape to CPR6L0. Some of the data that was restored were those areas that had the mini discs for maint, his 190 disk, his 191 disk, the 194 disk, and actually that new space we allocated for the, I guess, 494, what will become the bigger 194, and for 193 and for 294, we're allocating that space on that CPR6L0 disk. So most of the mini disks of the system, we didn't actually copy from the starter system disk to our system residence volume. The system residence volume has a bunch of space allocated for temporary space, for temp disks, for the spool space. We're continuing to use that CPR6L0 DASD as primarily our mini disk storage space. So it wasn't just that before, right? We were actually able to IPL from that, and it had obviously a CP nucleus area. It had spool and temp space. We don't need any of that anymore because we're never going to IPL that starter system again. So we're just going to reallocate the entire disk to be permanent space. You always kind of reserve cylinder 0 because if you were to put a mini disk on cylinder 0, you'd end up overwriting the volume label on the allocation track. So we're going to use cylinders 1 to 403 as permanent space for mini disks. This doesn't actually reformat or change any data on the disk, so we're not going to lose that data on the mini disks that are already there. This just tells VM370 which parts of this disk can be used for what kind of data. So that's kind of a long explanation to say, yeah, just follow these steps here, and we're going to reallocate the allocation map on this disk. Now it tells us to IPL from that format deck that was punched earlier. As I said, we can't do that, but luckily that starter system tape, if you remember, the very first file on the tape was the format tool. So let's go back to Hercules. start Hercules back up, telnet back into our system console, and put the starter tape back on the tape device, so 280. IPL from that tape. And then over on our console, which is here, not the shell, you can see, sure enough, we're back in the format allocate program because that was the first file on the tape. So we're just going to allocate. We're not going to format the disk. We're going to do that starter system volume, which is no longer the starter system volume. It's just going to become our mini disk volume that has a bunch of important mini disks on it. It's the 3330. It's CPR6L0. And then we're just going to kind of reserve that first cylinder by making it directory space and then permanent space from 001 through, it should be 403, right? Because it's a 404 cylinder disk. Yeah, through 403. This additional space is the footnote. That's if you had a 33-11, but we're just emulating a 3330-1. So 403 is correct. Okay, that's all we need to do. Let's shut down again. And then let's just start Hercules back up. Reattach our console. And for fun, let's connect a 3270 terminal. So C3270 localhost 3270. And I'm guessing the next step here is to IPL. Okay, so now it's actually reminding you of what was on that starter system disk. So again, if you're interested in the cylinder layout for the 3330 system, it's right there. So I think actually the beginning of step 19, did it also tell us to go ahead and, okay, yeah. So after we do that reallocation, then we IPL our new system residence volume. We will automatically be logged in as operator. And you can see that we're going to go through a startup sequence here where we'll see the time of day clock, and we want to do a cold start. So moment of truth, I guess. If we go back to Hercules, and if we attempt to IPL from our system resident volume, that's 131. Let's go over to our console. And so far, so good. It worked. So VM370 version 6, level 0, PLC 16. So our PTF tape there got us up to program level change 16, and that matches what the memo to users said. It said it was the memo to users for program level change 16. And sure enough, this CPU nucleus was built on February 6th, 2025. Okay, so we can see, because we told it our time zone, it's now operating in Pacific Standard Time. And if I look at my clock, that is correct. It is 11:51 p.m. on Thursday, February 6th. So this is looking good. We don't need to change the clock. We do a cold start this time. And you can see here, sure enough, we get to use all 16 megs of our storage because we remembered to make that change in that DMK sys file that we edited. There's no virtual equal real area. So yeah, this is good. This is the new CP nucleus that we built with the configuration that we provided. Okay, I'm happy about that. It's nice when things work. So let's skip by all of this information. So now it recommends you back up your system. We backed up our system a different way. We just copied those virtual DASD files. So we'll skip past that. Now we're logged in as operator. We need to format the 191 disk. So every user who's going to use CMS anyway should have their own private 191 mini disk, and CMS automatically accesses that as their A disk. So what we want to do is IPL CMS. Again, we don't have the CMS named system saved yet. So we still need to IPL just by the mini disk number. So we'll IPL 190 parm seg equal null. We're used to doing that by now. But instead of hitting enter at the CMS IPL prompt, we'll say access no disk. That will prevent it from trying to access the currently unformatted 191. Because remember, this 191 disk for operator in that directory, this is pointing to cylinders that were used for who knows what on the restored starter system disk, but we're now just going to start formatting to overwrite those areas and use them as mini disks. Okay, so IPL 190 parm seg equals null access no disk. IPL 190 parm seg equal null, and then access no disk. Perfect. Disk A not accessed. So then we just format 191 as disk A. Yes, we want to continue. We'll name it operator 191. Perfect. Yep. Okay, so we need to initialize the 191 disk belonging to maint the same way you initialized operator's virtual 191. So we're going to log off and log in as maint. And the password from that sample directory we used was cpcms. We need to define our virtual storage to be larger than the location of any discontiguous saved segments that CMS may try to use at this time. Ultimately, we are going to save our CMS segment. So that's why they're having us make a nice big, massive 2 megabyte storage allocation in our virtual machine. So let's go and do that. We'll log off and then log on as maint with the password cpcms. And we then will define storage as 2 megabytes. And anything else we need to do? Nope, just IPL CMS, same way. So IPL 190 parm segment equals null, access no disk. And then we can format 191 as A. Yes, we want to continue. We'll call this maint 191. Now, if you remember from the memo to users, it reminded us to also format those other new disks we created. So we formatted 191. We need to format the 193 disk. That was a new one. So I'm just going to stack these up at B for now. So format 193B. Yes, continue. So we maint 193. The other disk we created was 294. So format 294. And then just access it at B. Yes, maint 294. Okay. And we had that 494 disk. So format 494, and we'll keep it at B. Yes. Now I'm going to call this maint 190, 194, because this is going to be the new, bigger 194 disk. Okay, so that was 35 cylinders there. And if you look back at the memo to users, which is over here, here's where it just walks us through the simple steps of accessing the 494 disk as A, the existing 194 disk as B, and then we copy all of the files from B over to A and keep the old dates, the old file modification dates. We will then release disk B, which is 194, from our VM and actually, release it from CMS and then actually detach it from our VM. So let's do this. Access 494A, 194B, and then copy everything over. Access 494A, access 194B, copy everything from B over to the same name on A, and keep the old dates. So that'll just take a few seconds as 194 copies over. A lot of files on 194. Okay, that's done. So then we release B, detach. So 194 is gone. So now we need to edit the directory, delete the old 194, and change the entry for our 494 mini disk so that it is now the 194 mini disk. Then we bring that new directory online with the direct command. So if we look, remember our directory was copied to the 194 disk, so it should now be on our 494 disk, which should still be at A. So if I list just star direct star, sure enough, our release 6 direct file is there on A. So the only editor we have is the line editor. So we're going to edit release 6 direct A. And welcome to the CMS line editor. So we're going to locate the line that starts with user maint. That should get us to the right part of the file here. Yep. Okay, so from here, I want to locate the line for the old mini disk, which was 194. Yeah, here was the old 27 cylinder 194. So let's just delete that line. I'm now going to seek ahead to a line that contains 494. And indeed, that is our 494 mini disk, the new one, the bigger one with 35 cylinders. I want to change on that line the text 494 to 194. We just rolled over midnight, so CP on the operator's console prints out the timestamp every day. So it's kind of rude of it to just print something out in the middle of our editing session, but that's what that's all about. Okay, so that's our new modified line. It now reads mdisk 194, 3330, 153, 035. So that looks good. So file is save and quit. So now if we actually just type release 6 direct A, we'll verify that it still looks good. I can use tmux here to scroll up. So yeah, user maint, there's no more 194 here. Remember, it used to be between 193 and 199, and then our 494 is now 194. So it looks like we didn't mangle that file too badly. So we'll use the direct command to load release 6 direct A, and it accepted that directory, and it's now online. So we need to log off of maint and then log back in so we get a new VM that has those changes. So log on maint, cpcms, and the memo to user here reminds us to set the storage size to 2 megs and to IPL 190 parm seg equal null. So just like we did back here. Since we logged out, we lost that temporary change to our VM. So define storage 2 megs and then IPL 190 parm seg equal null. We don't need to say no access because we already formatted our A disk. So, we can query disk A and we see it is in fact accessed as our A disk. So that's the end of this note in the memo to users here. So we don't really need to worry about anything else specific from the memo to users. We'll just resume instructions from the Sysgen guide here. Although, not the memo to user, but the actual VM serve instructions up at the very beginning of this printout, I suspect we're going to refer back to those. So we're in as maint again. 191 is formatted. Those other new mini disks are formatted. Now we're going to complete the application of service. So we'll want to attach the PTF tape again. So attach 280 to maint as 181. So attach 280, that's the real tape device address, to maint as 181. The CMS tape archive tool always uses virtual tape device 181. So that's why we're attaching it as 181. Again, before we forget, let's go back to Hercules and put that tape back in that tape drive at 280. And see what we do next. Okay, so now we're going to load those files again to maint's 191. Remember, we had only loaded them to that temporary mini disk for the CPGen user in the starter system. now we'll get permanent copies of the VM serve exec and the supporting files on this new system's maint 191 disk. So we'll rewind the tape. I don't think the tape needs to be rewound, but we'll do it because it tells us to. And then we'll load the files, which will default to loading to our A drive. Okay, where are we? VMF PLC2 rewind, and then VMF PLC2 load. So there's those same files, and as expected, we got to the end of that file. Now if we list our 191 disk here, because we just formatted it, these are in fact the only files on maint 191. So the VM service program expects our 191 disk to be on C and not A. So we'll access 191C. And then we will restart the application of service and not display the memo again. So VM serve restart the product number. And then we're going to be doing the CP maintenance again. No memo. So VM serve restart. It's this number here. I'll just copy and paste. CP no memo. And that is going to start prompting us for information about applying the service again here. So enter CP base, so 194, that's correct. Remember, this is our new bigger 194 volume. Now 294, this is an entirely new volume for us. We're not going to load the source files because we didn't make those optional mini disks. We do want to apply CMS service at this time. The CMS system disk is 190. The staging area is 193. That's another one of those new mini disks we created. The instructions tell us to answer no about the RSCS because we have not generated and installed RSCS yet. So we'll say no to that. And then I'm also going to say no to IPCS because we haven't really done anything with IPCS yet. Okay, now it's doing some work. And it's still doing some work. If you look over at the Hercules console, we'll probably see, yep, it's running at about, 10 MIPS there. So it's thinking away, doing something. Okay, looks like it's probably done. We'll go back to the console. Okay, let's see here. So status DB servers loaded, loading some CMS files, loading the new CMS macro lib and text files. Okay, that's all good. So enter gendirty target disk mode letter. Null line defaults to S disk. That seems as reasonable as anything else. I'll just hit enter there. Okay, finished with the installation of the service tape. So CP service was loaded and CMS service was loaded. The CMS disk has in fact been changed. So the CMS disk is being re-IPL'd due to CMS disk changes. Now, notice that when we IPL CMS, it's still giving us this December 25th, 1978 date. This is where it looks like things have deviated from what we expect in the manual here. It was supposed to prompt us through actually generating that new CMS and installing the new IPLable CMS to our disks. We didn't get any of this. So I don't know if this is a change in how the service update stuff works from when this manual was written or what's going on here. But if we look back at this memo to users, if we go all the way back to the top, remember I said the first file that's printed are some of the instructions for the service tape itself. And this VM service program, we said VM serve restart CP. And that appears to have loaded all the CMS maintenance because it did ask us, do you want to do CMS maintenance? We saw that CMS was loaded. But I think we also need to go ahead and build the new CMS. So we're going to do that now. It's VM serve build program number again, and then CMS. So let's go back over here. We re-IPL'd CMS. We need to, in fact, we can see these files are still here on our A disk. But we're going to access our 191 as C again, because that's where vmserve expects it. And then we'll say vmserve, was it build or rebuild? Build that program number, CMS. There we go. Okay, so it's going to prompt us for those stationaries again. Those are all correct. Yeah, so now we're getting the set of prompting that the manual, the Sysgen manual, was talking about. So the system disk address, let me go back to the manual and we'll make sure we're getting this all right. So, right, that's our 190 disk. It's going to prompt us for this Y disk address. We do not have a 19E mini disk, but this is the mini disk where if we want to have additional local site generated programs available to all users, we don't want to keep filling up the 190 disk, which is really the CMS system disk. If there's a 19E disk, when CMS IPLs, it will automatically access that as the Y disk for the user, so those programs are available. So we'll go ahead and put 19E so that in the future, if we do give a 19E disk that we share to users, CMS will know to access it as the Y disk. So 19E, we'll tell it, yes, we want to rewrite the nucleus. We're writing it to the CMS system disk 190. We're going to need to figure out the last cylinder of that 190 mini disk. So we're going to need to look back at the directory for that. We'll also write it to IPL cylinder 0 so we can actually IPL from that disk. And then we leave version identifier and installation heading blank so that it should just generate the default IPL message there. Okay, that's a few things to remember, but I think we're going to be able to do that no problem. So the system disk is 190. That Y disk is going to be 19E. Yes, we want to rewrite the nucleus onto 190. And we need to use the last cylinder of 190. So let's go back out and look at our directory. Since we're already in here, we can't look at it right here in CMS. So let's just look at, we're already in 3270 here. I haven't started this device yet. We'll do that in a second too. But let me make a new terminal here just really quickly and look at those cards. Okay, so 190. So it's 85 cylinders. The mini disk is 85 cylinders. So that cylinder address is 0 through 84. So the last cylinder is cylinder 84. So let's go back to our console. That's going to be cylinder 84. Yes, we also want to write the IPL record to cylinder 0 and just hit enter for version identification and installation heading. And look at that. It just IPL'd our new CMS. And now our CMS was built on February 7th, 2025 at 9 minutes after midnight, which is the current time. So now we're confident that whatever service was on that tape is actually built into our CMS version that we're working with here. So let me go back over to, let's see, we're already on 1 here. Let's go to our instructions. Okay, so now we went through this process that the instructions said we should go to. So step 24 is to save CMS. So once again, so to save CMS, load it and then save it as soon after loading as possible. So we're going to re-IPL CMS again. Our storage, should probably already be 2 megabytes, but we'll just do this just in case. So define storage 2 megabytes, IPL 190 with parm seg equal null. Okay, and this time it does want us to press enter at the prompt, and then we're going to save CMS seg. So press enter, and then we're going to run the command access 190b/a, and then CMS xgen 100,000. So access 190b/a, CMS xgen 100,000. Okay, so that saves this CMS segment. Honestly, I have no idea what that means, but it's there now. Yep. Okay, and that 100,000 corresponds to something we defined in that saved name, system name table sample that we used. Okay, that also defaults to CMS seg. So all these messages we get in, about how the CMS segment isn't there, those will go away now because we now have that saved segment. Okay, so that all worked. So we can skip over this if things didn't work. And now we save the CMS system. So we're going to reduce our VM storage to 960K, and then we IPL 190. So define storage 960K. IPL 190. We're not doing that seg equal null thing because CMS seg now exists. We don't hit enter here. We want to save the status of the CMS system right here. And this way, when users IPL CMS, they still get the CMS IPL prompt so they can override their profile exec, they can not mount their disks, whatever they might want to do. So we can actually run save sys CMS right here at the CMS IPL prompt. System saved. Okay, so now it's re-IPLing for us. I think we can just go ahead and hit enter here. Yeah, so if it's successfully saved, we see system saved, you see the IPL prompt, you can just issue the CMS, IPL CMS in the future when we want to run CMS. So let's try that. Let's actually just completely log off from mate. And actually, I'm going to log on as operator again on this console. And this password is just operator. And I think if I say enable all, yes, that enables our 3270 terminals. So let's go over here. And what a beautiful sight this is. We have the VM370 little splash screen, I guess you'd call it, the logo screen. So we should be able to log on mate with password cpcms. There we go. We don't have an IPL, an auto IPL set in the directory for mate, but we can type IPL CMS here. And sure enough, we're in our newly built today, mere minutes ago, CMS system. So I hit enter. Here we are. We are in our 3270 in our newly generated VM370 control program and CMS. Very exciting. Okay, so this would be an optional step. If there's an MSS, you can do the MSS communicator program. We don't have that. And that's actually it. So we got through all of the steps. At this point, you can run the installation verification procedure. It does have you do this before you do other things like generate RSCS if you're interested in doing that. I think, this video has been long enough. We're over 2 hours now. So I think we'll stop here. We have accomplished our goal of performing a Sysgen of VM370. Let's switch back over to it. As I was saying, this is a pretty primitive system. We can demonstrate that here. Again, if I log on mate cpcms, IPL CMS, again, you can't say query disk. Like I would expect that to list my disks. For example, if I go, I'm going to switch back over to that 6-pack. So this isn't the system we generated, but if I go mate cpcms, if I say queue disk here, I get a list of all of the disks I've mounted. There's also a limitation to the number of disks you can mount in or access in CMS. So all of the letters aren't available. There's just a couple of predefined slots you can mount disks into. That's not a limitation on 6-pack or community edition as much. So as I was saying at the beginning of the video, there's a lot of nice work that's been done to make these turnkey distributions much nicer to use, and have sort of backported a couple of more modern features. But we didn't build these systems. We built this system from scratch, all by ourselves, using the tapes IBM would have mailed us. So we don't care that we can't say QDisk, because we can say QDisk A to see what we've accessed at our A disk, and QDisk Y to see it's not accessed, and QDisk S to see where the CMS system disk is mounted. As I said, the only editor here is the line editor. So even in the 3270 terminal, you're going to get, let's see. In fact, do we have 194 mounted anywhere? QDisk B maybe? No, let's access 194 as B. So if I edit release 6 direct B, which remember now is where the directory is on disk 194, we actually get a little bit nicer interface because we're on a 3270 terminal, but it's still the line editor commands to do things. It's just nice in that it shows you a little bit of context of the lines around it, so you don't need to manually run the print command or the display command to show the lines. But it's a far cry from the Xedit or the EE editor that's available as the full screen editor in the 6-pack or the community edition. But nonetheless, you all get the point. This is our baby. We generated the system all on our own by just meticulously following the instructions. So we'll leave it there. I'm not sure if I'm going to do really much more VM370 content in the future, but now that we have this system, I might do a little more research just to look into how you do some system modifications and maybe, try and patch in a couple of the niceties. So that may end up making a good video in the future. So we might revisit this, but I'll save the system just how it is today, so that if we pick up, we can just pick up right where we left off, and then I'll just make a copy of it to experiment on in the meantime. So I hope that was interesting. If you want to do this yourself, again, that manual is online. Those couple of tapes are online. That was all we needed to generate the system. And if you have any questions, comments, I'm by no means a VM370 expert at all. Like I said, I really don't use it much, so I probably can't answer any deep technical VM370 questions. But there are several people in the Mainframe Enthusiast Discord who can. So if you haven't been in there, feel free to join us there. And yeah, with that, I'll see you in the next video. Thanks so much for watching. Bye-bye.